Welcome once again to my new calculus channel. My name is John Gabriel, and today I'm going to show you once and for all that the MVT, or the mean value theorem as stated by the mainstream, is incorrect. So let's begin. You'll notice that in this, trying to get rid of this bar here. I don't know why I can't. All right, never mind. Let's just leave it there. So this blue function here is f of x, and its derivative is this light blue function. I'm sorry, its first derivative is the red function, and its second derivative is the light blue function. And the functions are these functions here. So this is f of x, this is f prime of x, and the second derivative of the first derivative of f prime of x. Okay, so I'm going to close it up. Now, the mean value theorem says that f prime of c is equal to f of b, the y-ordinate of b, minus the y-ordinate of a. And we can see that there is a c that gives us that, according to the mainstream, that gives us that level ordinate, or arithmetic mean as you call it in the vernacular. It turns out to be 0, okay? Because these points are equidistant from x is equal to 4. So the derivative of the red function is this light blue function. And we can see that even though there is no derivative at x is equal to 4, the mean value theorem doesn't care about it. In other words, we'll still have two c's, in fact, as you see at these light blue points, okay? Even though it's not differentiable at x is equal to 4. So let's look at the notes. According to mainstream mathematics academics, who are mostly idiots, f of x, this blue function, is differentiable at c, this point here, if f prime of x is equal to this expression, x minus 4 to the third, but not when it's equal to x minus 4 to the 4/3 divided by x minus 4. Somehow in their bird brains, x minus 4 to the third is not equal to the expression you see on the right here. Well, you'll have to ask them yourself why it's not equal. They're obviously mentally damaged. So in any case, the second derivative is not differentiable at x is equal to 4. So this red function does not have a derivative of 4, even though the baboons in mainstream say there's a tangent line there. And of course, I've always maintained, even from the new calculus, that there cannot be a tangent line at any point of inflection. But even so, the mean value theorem still works. Okay, so if you go back here, you'll see that it will work no matter where these points are positioned. All right, you'll always have the mean value theorem work. So the mean value theorem does not care about inflection points. And contrary to the mainstream statement, a function need not be differentiable at a point or at the point of inflection. So what's the conclusion? The conclusion is that a function f, which is, according to the mainstream, should be differentiable over the entire interval. And it's not always true. I've just shown you an example. So try this out yourself. Therefore, it is not a well-formed definition. It's wrong, in other words. And I know arrogant, incredibly incompetent and stupid mainstream academics don't like to be corrected, but I'm correcting them. This aside, the statement is entirely unremarkable, as it is a property of all smooth functions. You know, you cannot even apply the methods of calculus unless a function is smooth. And what does it mean for a function to be smooth? Well, simply this, that there is only one tangent line at every point in a given interval, and not more than one. And of course, this excludes inflection points. So stated correctly, the theorem says that if a function f and its derivative f prime are smooth, except at a point of inflection, over an interval ab, then there is a c such that the level y-ordinate, and notice I call it a level y-ordinate, not the arithmetic mean, because that's a flawed term. It's given by f prime of c. And as you see, f prime of c is equal to fb minus fa over b minus a. Moreover, the integral of f prime of x with respect to dx from a to b is equal to the product of two level terms. In the vernacular, level y-ordinate is an arithmetic mean, which is a fundamentally flawed term because really it has nothing to do with the middle of anything, okay? And mainstream academics don't understand what an arithmetic mean means, excuse the pun. So I wanted to clear this up because I've had some back and forth with one of my subscribers, Malachi Wadass, and hopefully after he's watched this video, if he's paying attention, he'll know exactly what my point was in the very first video that I referred to. My name is John Gabriel, and this is a new calculus channel. If you're not already a subscriber, become one, and also you can contribute credits or currency at the link I'll provide in the details section. Till next time, goodbye.